Onik, you can start.
Yes, Anik. Is this slide visible?
Yes, sir.
Yes, sir. Yes, sir.
So shall we start? Anik.
Hello, everyone. Good afternoon. It's truly a pleasure to join you all today for what promises to be an enlightening and timely session titled Glaciers from Space Applications of Remote Sensing in Cryospheric Science. On behalf of the entire organizing team at SAIARD, I take great pride in extending a very warm welcome to our distinguished speaker for the day, Dr. Riaz Ahmad Mir, Scientist C and Scientist-Incharge at NIH Western Himalayan Regional Center, Jammu and Kashmir. Dr. Mir, your remarkable work in the field of remote sensing, hydrology, and cryospheric science has significantly shaped our understanding of one of the most sensitive and vital components of our planet, the glaciers. The way you have been using advanced geospatial tools to explore these frozen landscapes from space is not only inspiring, but also immensely important in today's climate context. We are truly honored to have you with us this afternoon. Thank you for joining us and for taking the time to share your knowledge, insights, and experiences with us. I'm sure all of us here are eagerly looking forward to learning from your talk. With that, I would now like to request you to present your address or present your presentation to us, sir. Over to you.
Thank you very much. Please, can you tell me your name?
Yes, sir. My name is Antara Kundu. I am the program director at SAIARD.
Okay. Okay, Andhra, thank you very much. First of all, I would like to thank SAIARD, South Asian Institute for Advanced Research and Development, and the people who are there. I'm very much thankful to you that you have given me the chance to talk and deliver about the cryosphere and the studies related to cryosphere which we are conducting here at WHRC, which is a regional center of National Institute of Hydrology, which is actually based at Roorkee. And I am very much thankful to Dr. Biswajit Roy Chaudhary, who has actually, I think through LinkedIn, he has contacted me and sought my number, and I have shared my contact details to him. And finally, through that communication, it has been possible that we are today on this platform together. So I am also thankful to all the people who have joined through this platform, and I will be very much thankful to everyone that during this talk we will be talking about the glaciers, the cryosphere, how the cryosphere is being monitored by the workers throughout the world using different techniques, particularly using the geospatial technology, and also how the studies on the cryospheric science are being conducted in the field as well. So looking at your theme, application of geospatial technology in glaciology, I thought I should talk about the glaciers and see how remote sensing techniques are being implemented for study of these glaciers, which are one of the components of the cryosphere. And I think many of the people who are connected online, maybe the students and some people might be the workers who have been working in this field also. And so I have accordingly designed my talk that will mainly focus on the basics, because we know that we have sophisticated and advanced techniques, but starting from the basics, starting from the main basic foundation, I think that is which actually lays a strong foundation for detailed, comprehensive, and advanced studies. So I will be talking on the topic that is glaciers from the space and what are the applications of remote sensing in the cryospheric science. And I will be mainly focusing on the glaciers. And I will also show some details of our work which we are conducting in the field, and we have conducted many studies using remote sensing GIS also. So it will be a talk where many things will be shown. So starting from the first slide, that is what is the cryosphere. So before going to the advanced studies on the cryosphere, it is very much important that we should have the basic knowledge about cryosphere. That is what is the cryosphere, what is the definition of the cryosphere. Since we know that this cryosphere is a Greek word which means actually the icy or cold or chill-like thing, and the sphere generally refers to the ball, or which here refers to the globe. So the definition of the cryosphere is that the frozen water parts of the Earth's surface system, which includes the glaciers, ice caps, ice sheets, snow cover. Nowadays, very much is talking about the permafrost and the icebergs. These all frozen parts of the Earth fall under the category of the cryosphere. And these frozen components are found both on the surface.
Sorry to interject, but the slide has not changed. The first slide is still showing.
Okay. So is it now changing?
No, sir.
No,
It's still
sir.
showing the first slide.
Still first slide.
Okay, it is actually, this is the problem with always there.
Now
No,
it's staying.
Second slide, yeah.
Okay, okay.
Yes.
So when I am putting it on the slide show, I think it is not moving. Is it that?
Yes, sir. It's on the first slide still.
Okay. So, okay, I will just take it.
Yeah, now it's moving.
Okay, okay. So I was talking about the cryosphere. So cryosphere includes all the frozen components of the land as well as the oceans. As I have told you, that includes the glaciers, ice caps, ice sheets, snow cover, permafrost is included in the definition of the cryosphere. Since this cryosphere is very essential, you can see it can regulate the climatic system. It has a huge storage of the water, which is more than 70% of the fresh water. And the melt water which is coming from the cryosphere is directly contributing to the sea level rise, sea level dynamics. And there are many ecosystems which are dependent or directly or indirectly being influenced by the cryosphere. So this cryosphere forms very essential and important component of this Earth surface system. And nowadays, since we know that we are living in the times of the climate change crisis, we know that the climate is changing. And every day, I think on the daily basis, we get information and news about many types of the disasters which are coming out of this climate change crisis. So these glaciers are also responding very directly to the climate change. So these are also called as the direct indicators of the climate change. So as an indicator of climate change, the changes in the cryosphere is also very important. So monitoring of the cryosphere starts from here, where this importance is being explored in terms of being an indicator of the climate change, and that climate change impacting the glaciers or the cryosphere is finally impacting the water resources, that is impacting the hydropower generation, agricultural activities, and so many interrelated processes related to our economics or the economy of the nations. Now, out of this cryosphere, since we have seen that we have different components of the cryosphere, but I will be dealing mainly with the glaciers. Now, starting from the glacier, there is again the same question arises, that what is a glacier? General simple definition of the glacier is that it is a large, this long-lasting mass of the ice, which is formed on the surface of the earth, and it has one of the important characteristic feature, that it is under movement. It always moves under its own weight and under the influence of the gravity. And these glaciers are cover large parts of our mountainous regions. For example, we have the Himalayas, where we have large concentration of the glaciers, and the Himalayas, because of these large concentration of glaciers, is also called as the third pole on the surface of the earth. So these glaciers also comprise very important components of our Earth's surface system, because we know that these glaciers, for example, in the Himalayan part, are contributing the glacier meltwater to our major river systems, which includes the Indus River system, Ganges system, and Brahmaputra River system in our area. But knowing about the glaciers is not that we are only using the sophisticated techniques to monitor how the glaciers are changing. Actually, if you look at this slide, you will be getting reminding of your primary school classes, that when we started to study in our primary schools, this was a simple lesson, that what are the parts of the body, of the human body. So like that, if you look at the glaciers, it is very important, and we are supposed to study about the glaciers, and starting from knowing the these parts of the glacier as well. Like human body, the glaciers have its different components, different parts. As in this cartographic picture, you can see we have different parts of the glaciers. For example, if you look here, we have tributary glacier, we have lateral moraines, we have some foreign line is there, some crevasses are there, and some terminus and melting and evaporation point zones are there. Some terminal moraines are there. So in addition to this, there are many parts of the glaciers, which we as students or the workers working in the field of glaciology are supposed to know. And this cartographic picture, if you look here, we have this mountain glacier, picture of mountain glacier. You can see more or less, there is a similar features which are shown on this cartographic picture, and the same features you can observe on the these field pictures. You can see here different parts of the glacier, and you can also see these terminal moraines which are shown on this cartographic picture. On this pictures, field photographs, you can see these morainic features on these field photographs as well. But if you remind that knowing only the parts of the human body is not enough. Actually, human body is a complex system where we have a complex processes going on. Like that, this glacier is not so simple that looking at the picture or satellite imagery, we can identify, yes, this is a glacier. These are the different components and parts of the glacier. But if you look at the glacier is actually a system of one of the important systems on the surface of the earth, where we have contribution, some input is going inside the glacier and some output is going outside the glacier. Now, if you look at this picture, you can identify we have this accumulation zone of the glacier, and then we have this ablation zone of the glacier. And this cartographic picture, you can easily visualize these two parts of the glacier. And in accumulation zone, we have different components which are actually contributing mass to the glacier in the form of input. And in the ablation zone, we have different processes going on simultaneously where the glacier is losing mass. Means whatever glacier has gained, it is losing through this ablation zone. You can see in the accumulation zone, we have the major contributor of the mass to the glacier is the precipitation. In addition to this, we have other sources like rain, hail, there is freezing rain and snow accumulation. So many processes are going on there. And in the ablation zone, at the same time, you can see we have the melting of the glacier. We have the subaerial melting, sublimation processes. We have other processes like calming activities which are going on the glacier. So overall, if you look, this glacier is not as simple as you can see it in the satellite imagery or in the field, but actually it is a complex system of processes, dynamic processes which are going on there. And knowing about these processes is very essential if you are going to work in the field of the glaciology. And in this glacier, I have put this red dotted line, you can see it. This is an important line which is also called as equilibrium line altitude. So this altitude, this equilibrium line actually differentiates between the accumulation zone and ablation zone of the glacier. Now, how this glacier is formed? We know that glacier, the main ingredient coming into the glacier is the snowfall. Actually, when snowfall occurs, it is just as flaky material, but over the time period, it gets metamorphosed to form the glacier ice. And for that process, it takes hundreds and thousands of the years to form, to convert from just snowflakes to the glacier ice. So the glaciers which we see on the surface of our Earth in the Himalayan mountains have a long history there, which is spanning over hundreds and thousands of the years. So if we lose these glaciers, means we are losing an important commodity for which we have spent hundreds and thousands of the years for its formation. Now, after formation, as I have already mentioned, that glaciers have one of the typical characteristics is that they are moving. So the glaciers are moving by different processes. When glacier, for example, there is a vessel sliding movement, there is a plastic movement, there is some rigid zone where some brittle movement is also there. And when you look at the glacier surface, as a result of this movement, different features are also formed on the glacier surface. For example, crevasses. These are some sort of fractures, major fracture zones which are developed upon the glaciers. And these crevasses are very essential when we talk about the glacial hydrology part of this glaciology. So the movement of the glaciers is very essential. And nowadays, different satellite data is there which are implemented for the extraction and for monitoring the movement of the glaciers, because this glacier movement is very essential. It is controlling the glacier melting, it is controlling the glacier dynamics, and it is also controlling the glacial hydrology, which is very essential, keeping in view the climate change crisis and the water scarcity which is arising due to this climate change problems. Now, another process which is associated with the glaciers is the glacial erosion. For example, as I have told you that glaciers are moving, but when these glaciers are moving, they are causing the erosion. Means when the glaciers are moving on the surface of the rocks or the material which is there, it is carrying out many processes like plucking of the rocks, abrasion of the rocks, crushing of the rocks, and these glacial erosion features are very essential, which can also be explored, monitored using the satellite data. For example, if you look at this picture, you can see how the glaciers have been plucking this material, and this material is running with the glacier, and whenever the glacier is melts away, this material gets deposited in the form of glacial this landforms. So different landforms are formed also due to this glacier movement, due to this glacial erosion. And here you can see, this is one of the field photographs. You can see how the movement of the glaciers has just polished and straightened this rock body. I hope this picture you can observe, and whenever you are going into the field, you can observe such features in the mountain regions. If these features you can find in the field, you can obviously say, yes, sometimes there has been glacier, there has been movement of the glaciers in this region. Now, after movement, the glacier is plucking the material, eroding the material, and finally, there is a development of landscape, erosional landscape in the region where we do have the glacial deposits, glaciated ice. If we have glaciated ice in some region, we have some glacial erosional landforms there. For example, if you look here, we have these. This is an area where we don't have glaciers, but after glaciation, some erosional activities are being conducted there. And when the glaciers go away, you can see different types of landforms are formed due to this glacial movement or erosional processes, which are being carried out in the Himalayan terrain or other regions where we do have the glaciers. And you can see, you can classify these glacial landforms, erosional landforms. For example, you can see the U-shaped valleys, hanging valleys, cirques, arides, and horns in the terrains in the Himalayan terrain, for example, where we have this glaciated areas. Now, after that, the glacial has eroded the material. Now, it is the deposition which is being conducted by the glaciers. For example, when glaciers move, they take this material from high altitude regions where they have carried out this erosion, then finally taking that material to the low altitude areas, and they deposit these material in the form of different landforms. And these glacial deposits are generally called as the till. And we have different forms of these landforms, which are generally called as the moraines. Here you can see these are field photographs. You can see we have different types of moraines. For example, here you can see if the glacier deposits this material in front of its terminus, these are called terminal moraines. If the same processes are taking place on the peripheral parts, then it is the lateral moraine. If same process takes place in the middle part of the glacier, then these are the medial moraines. So these moraines, depositional landforms, are also very important indicators of the glaciation in the mountainous regions. And if you see anywhere in the Himalayan region, for example, if you are going into the field, into the Himalayan region, if you found some moraine type of deposit anywhere in the area, you can obviously say, yes, some glaciation period has been there in this area. So these are the diagnostic features of the glacial activity in the region. Now, how this landform evolves over a time period, you can easily visualize here. For example, this is a pre-glacial period. This is a landscape. This is a terrain. This is a mountainous terrain where we don't have the glaciers. Means this is a pre-glacial period. You can find some V-shaped valleys. You can find well-defined drainage patterns there. But after glaciation, you can see how glaciers have truncated this area, how they have eroded this area, and with the result, different types of erosional landforms have came into existence. In the second picture, you can see, means this is the glacial period where these activities are going on. After the glaciers melt away, these features are left behind, and you can see we have different types of glacial landforms which are there. So whenever you are going into field, no doubt there are no glaciers, but if these features are there, these glacial land features are there, you can obviously, and without any doubt, you can say, yes, this area has been glaciated sometimes. So this is how glacial landform evolves with time. Now, if you look here, these are some field photographs of the glaciers which we have taken in the field. For example, here, this is a glacier. You can see this is the accumulation zone of the glacier, and we have ablation zone towards the another side of this photograph, which is not shown here. And you can see this is the person who is there standing there. And this is the ablation zone of the same glacier. You can see these are some mountainous regions which are glaciated, erosional glaciated features. You can see these are called horns or arides, which you can, these photographs are from the Ladakh Himalaya. Now you can see it here. This is the terminus of that glacier. You can see we have a vertical column-like glacier terminus of this glacier, and the material and the rocks you can see in front of this terminus, which is the till or the glacial deposit. And when these deposits are formed in front of the glacier, you can see they develop in the form of moraines. So we have different types of moraines. We have another features like some glacial streams are also there in the field. These are some field photographs. If you are going to field, you can observe more and more such glacial features in the field if you can go to some large glacier. Now coming to the mapping of the glaciers. Now I have just gave you a brief idea about what is cryosphere, what are glaciers, how glaciers move, how they do this erosion, how they deposit the material, and what are the different types of materials they deposit, how the landforms evolve in the glaciated terrain. Now the question is why we should map these glaciers, why we should be concerned about the glaciers. Now we know that glaciers are the water towers of the river systems, and particularly, for example, in the Himalaya, we have major river systems. The water is coming from the glaciers. So the importance of the glaciers arises here because they are the water tanks, we can say. They supply water to the people, to the community, to the all activities which the humans are conducting. So the monitoring of the glaciers becomes very essential. There are many questions which are there. For example, how many glaciers are there in the world? Or we can say how many glaciers are in the Himalaya? How much ice do we have in these glaciers? Because the amount of ice is directly proportional to the amount of the water. So if we can quantify how much ice is there in the glaciers, we can obviously quantify how much water is available with us in these regions. So how, if the glaciers will melt away, how this melt water will contribute to the sea level rise, because sea level rise is one of the major issues and problems for the coastal people. So how likely and how quickly the melting of the glaciers will take place, for example, under the crisis of climate change. So how the glaciers respond to the climate change, because these are the good indicators of the this climate change. So there are many questions which are there. So that is why we conduct the studies on the glaciers, monitor the glaciers. And for that purpose, we generally have three well-defined techniques. One is the field survey and investigation. That is, we should go to the field, onto the glacier. We should monitor it, put our instrumentation there and monitor how glaciers are behaving, what is the amount of water, what is the amount of ice. That is a field survey. And another is remote sensing and GIS, which we will be talking more in this lecture. And then another is the modeling approaches. After getting the field survey, remote sensing data collection, we finally do the modeling of the different parameters, different processes of these glaciers. But the field campaigns, field work or field survey are really difficult because, for example, if we take the example of the Himalaya, we have a very high elevation. This is a very high elevated terrain, and we have very harsh climatic conditions there. And the accessibility to the glaciers is also not well defined. If people who are connected here have been to the glaciers, they might be knowing it, how difficult it is to be on the glacier in the high elevated terrain and cold type of climatic region, particularly in the higher Himalayas, for example. So sometimes this field survey and investigation becomes really very difficult, and we have to take into account large logistics into account, and that becomes really money consuming. So that is very difficult. So it is here the remote sensing and GIS has revolutionized the study of the glaciers and monitoring of the glaciers, because remote sensing data nowadays we have seen that there is a huge revolutionize in the launch of the satellites. We have huge satellite data available, so we can utilize this data easily and monitor the glaciers. And we have a large number of data set available from the remote sensing satellites. And most of the data is, I believe, most of the data is freely available for research activities also. Now, the use of the remote sensing and GIS and airborne imageries. Nowadays, UAV also is there. So this is very effective tool for improving our understanding about the glaciers, glacier dynamics, how glaciers are changing, how the glacier mass balance is changing. And these techniques are very haphazardly implemented throughout the world for the monitoring of the glaciers. And these is one of the efficient tools and methods for getting a huge data collection about the glaciers. And this remote sensing, GIS, and geographic information system and global positioning system now unmanned this UAV missions, they have just revolutionized the study of the glaciers, because we can have temporal dynamic analysis of the glaciers, mass balance stages of the glaciers, and we have a panoramic view of the all glaciers. We can monitor hundreds of glaciers together in a very small time of period also. So here the importance of the remote sensing and GIS becomes very important instead of field work. But still we suggest that using this remote sensing and GIS, there should be the field survey, so that the field validation is there, because the remote sensing and GIS studies also always need a field validation to validate our data. So this data validation, for that purpose, field data is always required. But this remote sensing analysis of the glaciers has revolutionized this study. Huge data has been generated, and we can also monitor the disasters which are emerging out of the glaciers. Now, if you look at the remote sensing, many people might be from geoinformatics background. They might be knowing much better that we have different components of the remote sensing, and major three components are the electromagnetic radiation, sensors, and sensor carrying platforms. We know that this electromagnetic radiation is very important, and the sensors are very essential for conducting remote sensing studies. And the platforms, for example, satellites, aeroplanes, UAVs that are carrying these sensors, these are also very crucial for conducting this remote sensing studies of the glaciers. And here you can see this is the electromagnetic spectrum, where we have different these spectrums. You can see this electromagnetic spectrum is exploited for the utilization in the remote sensing. And out of this, we have this visible, infrared, and microwave portions, which are very crucial for conducting this remote sensing studies of the glaciers. Now, how this remote sensing works, how this spectral behavior of the rocks and glaciers works, you can see from this example. Here you see we have this water body, we have some vegetation, and we have some barren surface here. And if you look here, the spectral behavior of all these three commodities is very different. So catching this signal, this diversity and differentiated spectral signature of these Earth surface features is very crucial. And this is the basics and basic foundation of how remote sensing works. Here you can see this is the reflectance curve of the soil. This green one is the reflectance from the vegetation, and this is the blue one is the reflectance curve from the water. So you can see this is the basics of the remote sensing. So this differentiation in the spectral signature and spectral nature of the Earth's surface material is exploited. That helps us to identify the different features of the Earth's surface features, as well as the glaciers which we have in our Himalayan region, for example. Now, for example, you can see it here. This is the spectral reflectance curves of the glacier. For example, we have the dirty glacier ice, clean glacier ice, we have fern, we have fresh snow somewhere in the glacier. So using this spectral signature, spectral behavior of these features of the glaciers, we can easily identify the glacier features. Now here, this is another example. You can see here, this is a reflectance spectra developed from the aster. You can see this is glacier. You can see the different spectral behavior at different parts of the glacier. So this information is being exploited while conducting the remote sensing of the glaciers, and this information helps us to monitor the glaciers features in the mountainous region in the world. Now, if you look here, we have different sensors. For example, we have Sentinel, Landsat, we have Aster, we have MODIS. In addition to this, we have other sensors there, and they have different spectral regions which are being exploited for generating this information about the glaciers or the Earth's surface features. This is also called as the spectral resolution. So depending upon the spectral resolution of the data, you can utilize it for the monitoring of the glaciers and mapping of the glaciers and understanding the dynamics of the glaciers. Now, if you look here, we have many sensors there. For example, we have Landsat, Spot, ICONOS, and these sensors have different resolutions, different spectral, radiometric resolutions, temporal resolutions. So depending upon your purpose, depending upon your motivation and objective, you can utilize the data out of these satellite data for monitoring the glaciers. And from the Indian remote sensing satellite, you can see we have a lot of remote sensing data available from our missions, which are being conducted by the ISRO. So you can see we have, for example, Cartosat, ResourceSat. These are the different satellites and the data which are being utilized for conducting the glaciological studies. In addition to this, we have some data. Most of the data are freely available. For example, Landsat data, which is a long time series data available from 1970s till now. Different sensors are there, and the resolution is also very variable. Nowadays, the resolution of the data has improved very much. So that data we is freely available. We can download data and use in the glaciology. In addition to that, if we want high resolution data, some data products are commercialized, and this data, for this data we have to pay. But this data is really very good because they have the high resolution. For example, if you look at the spot, we have 1.5 meter resolution of the data. So within 1.5 square meter, you can gain the information. You can take the data from the glacier surface if this data is available with you. Now, out of this, I will focus on this Landsat data. This is really very important data set which is available to the glaciological community, particularly to the students, because students don't have the funds to purchase the commercial this data sets. So if you look at the Landsat data, this data has been available from 1970s till date. And there are different Landsat satellites carrying different sensors. For example, if you look, we have this MSS data, TM, thematic mapper, ETM. It has improved with time. And if you look here, we have different bands there, which are actually the different wavelength bands there. So depending upon that wavelength, we have different resolutions. And band 8, you can see we have 15 meter resolution of this data set. And generally, we have 30 meter resolution of this data set. And this data has been extensively used for the glaciological studies. And this is very good data set available if you want to know the temporal change and temporal dynamics of the glaciers. And this data set is very freely available. In addition to this, we have different instruments, different data sets as is tabulated in this table. You can see we have different data sets which are being exploited for utilization in the glaciological studies. Now, if you look here, I have some photographs. For example, people have been using the historical topographic maps. The Geological Survey of India has developed in India first glacier inventory for the Himalaya, and they have mainly used the data from these topographic maps. And here you can see how the glaciers have been mapped by topographic maps. So this data is very old. This can be utilized for understanding the temporal dynamics and temporal change of the glaciers. This is one of the important data sets. In addition to this, we have some aerial photographs which are very old, which have been used by the US for some surveillance purposes right in 1960s and 70s. This data can also be used, and people are actually using this data set for monitoring the glaciers, because the glaciers are changing. In order to monitor the change or the dynamics or the temporal dynamics of these glaciers, this data is an old data archive which can be utilized for monitoring the glaciers. Now, if you look at the Landsat data set, we have different data sets. You can see MSS since 1972, this data set is available. So this data set can be continuously utilized for the monitoring of the glaciers. And this data is freely available. We have different data sources. Different websites are there available where you can download this data, analyze this data, and process the data. Nowadays, the Google Earth engine, which has emerged one of the very fast, quick, and very easily accessible tool where you can analyze the data online. You can download, you can see the change analysis in the glaciers or the land surface features. So the data is freely available in this Google Earth engine. This is newly emerging technique you can be using for monitoring the glaciers. Now, coming to the glaciers, what are the parameters which actually we need to monitor to understand the behavior of the glaciers or to understand the glaciology? You see, I have just started from the basics. I have shown you some pictures of the glaciers. parts of the glacier, different erosional, depositional land features. Then I have shown you the different types of satellite data that can be utilized for monitoring the glaciers. Now, what are the parameters where we are interested? We want to quantify so that we can understand the glacier as a whole body or the system for monitoring. So starting from there, you can see I have put about 20 parameters there, which are very crucial and which are actually monitored while studying the glaciers. Here, first one is the inventory, means how many glaciers are there, that is inventorying of the glaciers. So this is a simple method. You can map the glacier, count the number of the glaciers, and generate the inventory of the glaciers. Another thing is how the glacier ice is formed, how it evolutionizes with time. Then what is the glacier accumulation, glacier ablation, what is the behavior of the equilibrium line altitude, what is mass balance gradients, glacier response time, glacier deformation, which is related to movement of the glaciers, then glacier fluid velocity, and then glacier classification. After doing inventorying, glaciers are supposed to be classified because we have different types of glaciers. Some glaciers are large, some glaciers are small, some glaciers are debris covered, some are clean. So there is well-defined classification of the glaciers. So accordingly, after inventorying the glaciers, you can classify the glaciers. So what is the area? How much area glaciers are covering? What is the extent of the glaciers? What is the length of the glacier? What is the parameter of the glacier? What is the snout terminus of the glacier? Whether it is calving into the sea or lake or into the land, or is there some terminal moraine where it is terminating there? So all these parameters, and volume is very much important. How much ice is there in the glacier? Then mass, slope, perspective, morphometry, and then finally glacial hydrology. So all these parameters can be extracted using the satellite data. So if all these parameters we are able to quantify, we are able to understand and map, that becomes the field of glaciology. If you can do this, so you will become the expert in the glaciology. Now, starting from mapping of the glaciers, there are many techniques. For example, if you have a satellite image, if you have a topographic map, if you have aerial photograph, you can simply digitize. You can simply demarcate the boundary of the glacier. That is manual on-screen digitization. And using the satellite data, you can generate this false color composites so that you can differentiate between the glacier ice and the terrain which is there. Different techniques are there. You can utilize that to map the glaciers, because finally, first step is that we want to map the glacier. What is the extension of the glacier? And in addition to this, we have some band ratioing techniques also available there, where you do the statistical analysis of different bands. For example, some formulas are there where you subtract or divide, or even many processes you can conduct. So depending upon that, you can develop the glacier maps. Then applying some algorithms also, like supervised, unsupervised classifications. Nowadays, machine learning techniques you can also use. Some artificial intelligence techniques you can also use to map the glaciers from the satellite data. Then some well-defined spectral indices have been developed, like NDSI, NDWI, natural water index and snow index. You can utilize this for mapping of the glacier as well as the glacier lakes or the water bodies. So in addition to this neural network, artificial intelligence, machine learning, Google Earth nowadays you can utilize for the mapping of the glaciers. For example, if you are using the satellite data, there are certain diagnostic features. If you look here, we have these characteristic features which we try to perceive from the satellite data and demarcate the glacier boundary. For example, we have the shape, size, we have the color, tone, texture, pattern, association, shadows, and other contexts. So these are actually used when you are doing the digital or manual identification. Manually, you are delineating the glaciers. So using these diagnostic features, you can identify the glacier terminus, you can map the glaciers. And there are other features, like we have the breaks in the surface slope, spectral color differences, some braided streams, some streams are emerging from the snout. These are diagnostic features which you can utilize for mapping of the glaciers. Because using satellite data, mapping of the glaciers is very difficult sometimes, particularly when the snout part of the glacier or the terminus part of the glacier is covered with the debris cover, because the debris cover and the surrounding slope sometimes have the same spectral signature. So it becomes really very difficult to differentiate between the ice and the surrounding terrain because of that debris cover. Here you can see, this is the picture. You can see some water body is there, and otherwise you can see there is no difference between the surrounding slope and the glacier surface. But since the water body is there, we just infer from this diagnostic feature that yes, the glacier is terminating here, glacier is ending here. This is the snout of the glacier. So these are diagnostic features which you can utilize for mapping of the glacier using satellite data. But when the glaciers are clean type of glaciers, then you can easily identify the glaciers, because there is a huge difference between the spectral signature of the terrain and the ice. You can easily demarcate the glaciers and digitize the glaciers. For example, in this satellite imagery, you can see very clearly, you can identify the water bodies, you can identify the terminus of the glacier. You can also identify some moraines. You can see these running line features. These are nothing but the medial moraines or the terminal moraines are there, and lateral moraines are also there. You can easily identify using this satellite data and demarcate the boundary of the glacier. Even you can demarcate the accumulation zone. If you look at this here, at this picture, you have some dull type of coloration or tone here, but you have really bright tone here. So you can demarcate between the accumulation zone and ablation zone of the glacier using this type of satellite data. But the problem arises only when there is a huge debris cover. For example, in the Greater Himalayan region, we have huge debris cover on the terminal part of the glacier. So that time it becomes really difficult using satellite data. At that time, you have to use other indices, diagnostic features to map the glaciers. Now, looking at this another map, you can see if you put the satellite data, drag it over this some 3D, this digital elevation model. We have different types of digital elevation models, so you can generate a 3-dimensional view, and you can easily demarcate the boundary of the glaciers, water bodies, where is the terrain, where is the mountain, how is the stream behaving. So easily you can demarcate the glacier using this satellite data. Now here, if you use some band ratioing techniques, for example, here you can see we have thematic mapper, band 4, band 5. You can do some calculations, you can band ratioing, so you can generate maps where some features are, these glaciers are become really discernible, easily discernible, so you can then map these glaciers. For example, here you can see how these glaciers, automatically you can do the mapping of the glaciers, and you can then generate this inventory. And this is Google image. Here also you can see this is a true color image, Google image. You can easily see this is the glacier and this is some water body there. So using these types of satellite data, you can easily map the glaciers using different techniques, like manually you can do it, or using some band ratioing techniques also. So once the glaciers you have demarcated, you can automatically develop the vector files of the glaciers, and you can develop the inventories. You can calculate the area of the glacier ice which is there in the area of your interest. For example, here you can see this is an inventory. For example, in 1973, the glacier has been along this blue boundary, and in 2001, you can see how glacier has changed. So you can demarcate the glacier during different time periods, and you can easily demarcate how glacier has been changing over time period using satellite data. And here you can use automatic techniques, or you can do it visually, manually, so that you can understand the temporal behavior of the glaciers. In addition to this, as I have already told you, that we have different indices, well-defined indices. You can use these indices. These are the formulas depending upon the wavelengths, which are called the bands of the satellite data. So you can use these indices for mapping of the glaciers. And here you can see we have different indices. People have developed different indices. And you can also develop and generate these indices if you are working in this field of, in this domain. Now here, mapping the debris cover. You see, this is the glacier. You can see some ice is there. But the frontal part, if you look here, we have huge debris cover. And if you look at the color or the tone, you can see it is similar between the surrounding terrain and the tone on the glacier surface. And this is the debris cover. So here we have to use, we have to rely on other diagnostic features to map the debris cover, because debris is on the surface of the glacier and we have glacier which is beneath the debris there. So if you are supposed to map this glacier, we are supposed to map the glacier under this debris also. So for that, as I have already mentioned, that we can use different types of indices. In addition to this, we can also use thermal bands, which is associated with the satellite data, because thermal band is giving us the information about the temperature. So we know that the debris which is above the ice may have at low temperature as compared to the temperature on the surrounding slopes. So using that temperature difference, you can demarcate the debris cover, you can delineate the debris cover, and you can conduct the mapping of the debris covered glaciers as well using the satellite data. Now, after doing the mapping, you can generate the inventories, and here you can see this is the map showing the inventory during generated different time periods. For example, in 2011, showing this yellow outline, and in 2014, showing this black outline. You can see how the glaciers are behaving, how they are receding, how they are retreating, and you can generate the count, you can generate the inventory, you can generate many parameters associated with this inventory, and you can conduct such types of studies in the Himalaya, in the basin, in the catchment wilds, depending upon the purpose of your study. Now, you can see one of the important characteristics of the satellite is that they give us the panoramic view. You can see this is the first inventory, global inventory, Randolph Glacier inventory, which has been developed for the whole world. And we have about 2 lakh glaciers in the world. And you can see this has become only possible using the satellite data, because the data has been used and the glaciers have been extracted automatically. And finally, this Randolph Glacier inventory has been developed. So this is the beauty of the remote sensing data, where you can do large areas, where you can analyze, map the glaciers automatically within no time, covering large areas. So this is the global inventory you can see. Here you can also see we have the inventories which have been generated for the Indian Himalaya, like we have this Western Himalaya, Central Himalaya, we have Eastern Himalaya, and we have different basins like Indus, Ganges, Brahmaputra. So different people have conducted studies there. They have tried to see the number of the glaciers. For example, in Indus Basin, we have more than 18,000 glaciers. In Ganges, we have about 8,000 glaciers. In Brahmaputra, we have again large number of glaciers, about 11,000 glaciers there. And this is the area. You can also see how much area is covered by these glaciers. And this regional type of glacier study has become possible only using the satellite data, which is available from the satellite or the geospatial technology. So you can see from Western, Central, Eastern Himalaya, we have the count of the glaciers, we have the count of the number of glaciers, glacier area, what is the volume. So people are working on these, and people are frequently updating the glacier inventory data and the information about the glaciers. And here, these are some examples from our studies. You can see this is Baspa Basin in Satluj River Basin. You can see we have also developed, tried in Sungal catchment. We have developed the glacier inventory there for different time periods. And finally, we have come up with a glacier area loss map. You can see this red color is showing the loss of the glacier ice from 1970 to 2011. You can see this is possible only using the satellite data. Now, another study, you can see how the glacier has been changing from 1966 to 2011. You can see 1966 outline of the glacier, and 2011, there is no ice. The ice which was there in 1966, that has been gone away, that has melted away. And in 2011, you can see this is the outline of the glacier. And from this glacier, you can more or less also see the accumulation zone and ablation zone depending upon the tonal variation. And if you look at this picture, you can also see this frontal part is hugely covered by the debris, because you can see there is a similarity between the tonal characteristics of the surrounding terrain and the glacier surface. Now, you can also use aerial photographs, which has been used for the surveillance by the US government in 1960s and 70s. But people have used this data because this is high resolution data. And you can see how this glacier has been changing over time period, and this data can also be used for different purposes. People are using, and here this is an image of a corona one of the glaciers in Ladakh, Himalaya, Parkachi Glacier, and you can see how glacier frontal part has been behaving over the time period from 1962 to 2015. So this is one of the important glaciers keeping in view the Gangotri, Ganga River. This is the source region of the Ganga River, Gangotri Glacier. And you see, this is the satellite data showing you the location of the snout during different time periods, right from 70, 80 to 2001. So you can easily demarcate, visualize, perceive what is happening with the glaciers using satellite data. And this is the panoramic view, which is possible only through the satellite data. Otherwise, if you look here, this is the field photograph. You can only see this part of the glacier, not beyond this, because it is really very difficult to go up into the, for example, accumulation zone of the glacier or different parts of the glacier, because glaciers are sometimes very long, about more than 10 kilometers long. So it is very difficult, and we have different types of features on the glacier, like we have crevasse, we have mullions there. So it is really difficult. But satellite data has provided all this panoramic view of the glaciers and has made it possible to monitor the glaciers globally, locally, as well as basin-wise, catchment-wise, depending upon the purpose of the study. Now, if you look here, we can also monitor the length changes of the glacier, snout changes of the glacier. Here, some few examples are there. You can see how the glaciers have been behaving during different time periods using this satellite data. Now, the length that I have already shown you, people have conducted many studies where they have, in the Himalayan region, where they have shown how the snout or the length of the glacier is changing. And this is one of the study. You can see many data is available there. And this data is possible only using the remote sensing satellite data. Now, coming to equilibrium line altitude, I have already discussed this. It is the line where the this accumulation and this ablation is in equilibrium, means there is zero accumulation as ablation. That is called the equilibrium line altitude. Monitoring this equilibrium line altitude is also very essential. So it can also be done using satellite data. For example, here you can see this is a glacier. Here we have demarcated this snow line, which is more or less equivalent to the equilibrium line altitude. So if you look at this satellite image also, you can see the tonal differences, and you can demarcate this equilibrium line altitude. Changes in the equilibrium line altitude over the time period are the critical and important diagnostic features of the behavior of the glacier, which is behaving in response to climate change. Now, another thing is the mass balance. People have developed different techniques for mass balance estimation. So you have, for example, accumulation area ratio technique is there, which is available where we have this formula. So if you can develop the data from the satellite data, for example, accumulation area, total area of the glacier, you can develop this accumulation area ratio and estimate the mass balance of the glacier. In addition to this, we have different digital elevation models, and subtracting these different elevation models of different time periods, you can estimate the surface elevation changes of the glaciers. And finally, you can estimate the mass balance change, that is changes in the mass of the glaciers using the satellite data. For example, here you can see these are some glaciers where we have ablation zone, this is accumulation zone, and this is somewhere this equilibrium line altitude. So using that formula, we have tried to see the mass balance of these glaciers. And you can see most of the mass balance is negative, means glaciers are losing mass. And using these elevation models, we have also tried to develop this geodetic mass balance, where we subtract two digital elevation models of different time periods. And we have conducted also such type of studies, and people are also doing this type of study globally. A lot of data has been generated using this geodetic remote sensing based technique for glacier mass balance estimation. For example, here you can see this is one of the geodetic mass balance studies from the ICMOD, and you can see how the Himalayan region, Hindu-Kush Himalayan region, we have negative mass balance, and you can see how the glaciers are losing mass in the different parts of the Hindu-Kush Himalayan region. And this has become possible only using the satellite data, which can't be done using the field data, because field data, we can't access to all the locations, all the areas, which are spatially very extensive and very difficult to access. Now, using this data, you can develop the mass balance trend over the time period, and it is observed that glaciers throughout the world are losing mass, means the glaciers are going away, and the implications of that are that we are having the water security issues arising out of this mass balance or glacier melting, which is going on throughout the world and also in the Himalayan region. In addition to this, we can also estimate the movement of the glaciers. That is, we can also conduct velocity estimation, and there are many techniques, many data are available. For example, feature tracking using optical data, satellite data you can use, and you can monitor how glaciers are moving, how glaciers are behaving, what is the dynamics of the glaciers. In addition to this, SAR interferometry techniques are also available for monitoring the glacier dynamics. And here you can see these are some examples. Here these vectors are showing the movement of the glacier, and this can be done using the satellite data. So we can infer about the movement of the glaciers. And out of this movement, we can also understand the deformation of the glaciers in the region, because deformation of the glaciers are responsible for many surface features or the deformation of the glaciers within the glacier which are there. So these also control the glacial hydrology and melting and mass balance loss of the glaciers. So this can be done using the remote sensing data. Here some examples we have tried to do this. You see, this is one of the glaciers, Jammu Glacier, and we have conducted this velocity map there, and you can see the vectors are showing how the glaciers are moving, in which direction they are moving. And using the geodetic mass balance, we have also tried to estimate the elevation changes in this glacier. These are some examples I am showing, and this is one of the glaciers where we have conducted this velocity change, surface displacement. You can see where we have this blue color, we have higher velocity there, where we have this yellow type of color, we have low velocity there. And these are the ice thickness measurements using satellite data. We have higher thickness, for example, this blue color indicates thick part of the glaciers where we have more than 195 meter of thickness, and this red part show the low areas where we have low thickness of the glacier, and this has also become possible due using this satellite data. In addition to this, we can develop the glacier topography and morphometry, for example, slope, aspect, elevation, relief. So this can be done using the satellite data. Some glaciers are surge type of glaciers. Here you can see, and this can be done only using the satellite data, because surge type of glaciers are glaciers which sometimes move very fast within small time of period, and sometimes these glaciers become hazards because they block the flowing rivers and create some temporary lakes, and that can result in hazardous situations. So monitoring this surge type of glacier, we can use the satellite data and see what is the surge activity, how the glaciers are behaving in the area where we have surge type of glaciers, and this has become possible only through the satellite data. Then we can also know the glacier surface temperature dynamics and variation using satellite data. We can generate the surface temperature maps of the glaciers. Here you can see these are the surface temperature maps of the glacier, and you can see with elevation, with slope, with aspect, how the temperature of the glacier is behaving, and this can also be done using the satellite data. In addition to this, we can also monitor the glacier lakes which are formed due to the melting of the glaciers. When glaciers melt, huge meltwater sometimes gets accumulated behind the moraines, which are the glacial deposits. I have shown the moraines. So sometimes these get accumulated there, this water, and these generate glacial lakes, and these glacial lakes are really very hazardous. For example, we have been witnessing many glacial lake outburst floods. Recently, we have witnessed the South Lorak Lake disaster in the Sikkim Himalaya. So monitoring glacial lakes can be easily done using the satellite data. Here, these are some examples where you can see the glaciers. These are the covered parts of the glacier, and how the glacial lakes have formed. Huge glacial lakes have formed in front of these glaciers. So this type of study can also be done using the satellite data. And here you can see how many types of supraglacial, means glacial ponds forming on the surface of the glacier itself. Sometimes these supraglacial lakes coalesce together and develop large glacial lakes. So we can monitor how these small glaciers develop, form, and how they can merge and finally result in the formation of large lakes. This can be done using the satellite data. Now, if you look here, we have also mapped this glacier and glacial lake. You can see how glacier has been retreating over time period and how the lake has been expanding over time period. And this study we have conducted in the Zanskar Himalaya, and we have also conducted the glacial lake outburst flood modeling of these two lakes in the Zanskar Himalaya. And this expansion of the glacial lake and recession of the mother glaciers has become very clearly visible and perceivable using the satellite data only. In addition to this, you can also conduct the geomorphological mapping using the Google Earth data, which is very good data set, which is high resolution data set. And here you see, this is the frontal part of one of the glaciers, which is called Parkachi Glacier. And you can see different moraines are there, crevasses are developing there. And this is the frontal part of the glacier. So we have tried to develop the glacial geomorphological map of the frontal part of the glacier out of this Google Earth image data. So it can be easily done. And then we have also went to the field. We have validated these satellite-derived features, glacial landforms there, and we have validated these features in the field also. So this is the beauty of the satellite data, where we can develop the glacial geomorphological maps also. I have shown you the different glacial geomorphological features, both erosional as well as depositional features. So using satellite data, we can map glacial geomorphological maps. We can develop glacial landform maps using high resolution satellite data. And Google Earth is one of the best data sets, which is freely available, accessible to everybody. That can be done, provided the satellite data is not covered by the snow cover or this cloud cover. So here you can see we have also tried to map the glaciers, different types of glaciers, and then different types of lakes in the Baspa Basin. You can see this is the type of classification we have conducted, and this is the type of classification for glacial lakes. And you can easily see different types of glacial lakes and different types of glaciers are there in the region. And this can be done using the satellite data. This is not possible using the field data, because most of these small glacial parts like Nike glaciers, Sir glaciers, glaciers, these are really located at the high elevation where accessibility is deadly impossible. So this can be done using the satellite data. These types of maps can be developed, and the quantification of ice, water content in the maps can be done, and hazard assessment of these glacial lakes can be easily done using the satellite data. Now, in addition to this, you can monitor the snow cover. Snow cover is very important. Here, for example, this is the MODIS satellite data. You see, we have developed for the whole year, starting from January to December, this snow cover maps. So you can see how the snow cover is varying with season. For example, if you look at here in January, we have a lot of snow cover area. But if you look in August and this July to August, we have minimum snow cover. In August, we have normally only glacier ice there. Snow, the seasonal snow gets melts away. So you can develop these snow cover maps, and these snow cover maps are utilized for snow melt runoff modeling. You can develop snow runoff models for which these snow cover maps are used, and these can be easily developed using the satellite data. Depending upon the resolution, depending upon your area, you can develop and use different types of data for this purpose. And finally, I will show you one of this case study which we are conducting in Ladakh Himalaya. You see, this is a study area in the Ladakh region. You see, this is Leh. Many people might have visited Leh, and this is Khardungla somewhere here. And this is the glacier inventory which we have developed in these small catchments around the Ladakh region. In the Leh town, this is Leh. Leh is located in Ganglas catchment. You can see it here. And we have this Puche Chu. This is the Nala or Gangla stream, you can say there, which is supplying water to this Leh town, which is a tourist hub region in the Ladakh Himalaya. And in this region, we have this 47 number glacier there, which is called Puche Glacier. We are monitoring this glacier in the field also. And this glacier 40, this is a Khardung Glacier. just near the Khardungla top. These two glaciers we are monitoring in the field, and this is inventory generated from the satellite data. And here you can see it. This is the Fuche Glacier, and this is stream coming out of this Fuche Glacier. And then finally, we have a base camp here, NIH base camp, this South Kullu somewhere here. And this water is directly going to the Leh town and supplying water to the people of the Ladakh in the Leh town. And we have hotels there, we have people there. This is a whole tourist hub place. And this meltwater is also contributing to the groundwater there. And people are utilizing that water for many purposes. They are particularly for drinking purposes. So we have been monitoring this area in the field right from 2010 onwards. So about 15 years have gone that we have been monitoring this area. And this is Fuche Glacier. You can see it, Fuche and Khardung Glacier, which we are monitoring in the field. Now, if you look, these are the different characteristics of these glaciers, which we have been monitoring in the field. And this we have extracted using the satellite data. And for Bangla's catchment, you see, we have only 2 glaciers there covering less than 1 square kilometer of the area. But this 1 square kilometer of the ice cover is very important for the Leh town, because the Leh town is developing very rapidly. Huge development has taken place there. As I have told, this is the tourist hub place. So the importance of monitoring these 2 glaciers becomes really very crucial and very important. Now you see here, we have been monitoring these glaciers right from 1962 to 2023 using the satellite data. And these are the satellite images showing the outlines during different time periods of these glaciers. And mainly focus on this glacier 47. This is the Fuche Glacier, which we are monitoring in the field also. And you can see this green, light green outline, how this terminal part of the glacier has been retreating backwards during the last 3 to 4 decades. And here you can see this is the frontal part. We have this dead ice bodies there, and these are just separating from the main terminus of the glacier and becoming dead and finally melting away. So you can see here we have how this glacier is changing, how the glacier ice is becoming and losing there. And same for the Khardung Glacier, you can see same process is happening there. And in addition to this, if you look here, this another glacier 41, you can see from 2000 to 2023, if you look the terminal part, in 2000 we have no water body there. In 2070, some water body has formed there, some water has accumulated there, and in 2023, a well-developed lake has developed there. Now, if the same process continues, this lake may become vulnerable to glacier lake outburst flood in future. So the community living downstream in the area below this lake may become vulnerable to hazard, to the disaster, which we have been witnessing in the Himalayan region. And just a few days back, we have witnessed another disaster in Darali area of Uttarakhand, Uttarkashi. So these processes are going on in the Himalayan region. So satellite data gives us a temporal overview of the glaciers, but monitoring some selected glaciers in the field becomes very essential, because field validation is important for monitoring, understanding the dynamics. For example, in case of Fuche Glacier, from satellite data, it is not possible to see these dead ice patches or the dead this debris cover. But when going to the field, it has become possible how the glacier is breaking, how the glacier is melting away. It becomes possible only in the field. And taking that idea and that understanding, it can be implemented to the large number of glaciers, that same understanding, that same processing which is happening there. So you can see here, we have tried to see how much glaciers have been changing. For example, in case of Ganglas, we have seen that from 2000 to 2023, means last 2 decades, 10% of the area of the glaciers has become vanished, has been lost. And then we have tried to correlate with morphometric parameters also. And these morphometric parameters we have derived using the satellite data. This is done to understand the dynamics, how the glaciers are changing with respect to elevation, slope, aspect. So this is a detailed study. These type of studies can be done. So finally, if you look here for this Ganglas catchment only, we have this Fuche glacier here and another glacier is small glacier, but we are not monitoring this glacier in the field. On the Fuche glacier, we are monitoring in the field. And this is South Pulu where we have base camp. And the meltwater is coming from this glacier and contributing water to all this urbanized area of the Ladakh. And we have also developed a hydrogeological map of this area where we have tried to see how the glacier meltwater is infiltrating into the ground and how it is contributing to the groundwater. And finally, we have tried to see how the extraction from the people are impacting the groundwater resources in this region also. So if you look for this Fuche glacier, we have a loss of about 11%. And for this another glacier, which is glacier number 20, we have about 12% of loss in area from last 2 decades. Now, if you look here, this is the hydrogeological model. You can see this is the meltwater coming out of this glacier and going into the Gangla stream and supplying water to downstream areas. But if you look here, we have this meltwater also accumulating here, but directly infiltrating into the ground. Means this water is infiltrating into the ground and finally contributing to the groundwater there. So the glacier meltwater is not important only in terms of stream water, stream flow, but also in terms of groundwater. Because here you can directly see in the field, yes, this groundwater is infiltrating into the ground. And if it is infiltrating, where it will go? It will automatically join the groundwater which is there. And this is groundwater level table. You can see it in the Ladakh region. And people are exploiting this water, digging their bore wells, using this water for day-to-day use there. And this groundwater is available in these morainic deposits. I have already shown you the depositional features, depositional deposits of the glaciers. So this all material is generally and dominantly a morainic deposit. Now it has become a storehouse for the groundwater there, which is being used by the people there. Now, if you look here, we have also conduct field-based mass balance studies. And you see here, we have automatic weather stations also there, monitoring the climate. We have some ground sensors also there, and we are conducting field-based mass balance studies. In addition to geodetic mass balance, we are also conducting field-based mass balance studies, and we have been putting stakes there. And every year, 2 times we go to there and collect the data. And you can see this is the graph. You see the Khardung Glacier is losing mass. The mass balance is about 7.9 meter water equivalent. And for Fuche Glacier, we have 2.14 meter of water equivalent. So this is the field-based mass balance study. Now, this photograph is just a recent photograph I would like to show you. Here you see, this is a stake which we have installed in 2023. And this is tip. Here, tip, that time, just 2 inches of this stake were exposed. And this year, in July last month, we have been there. And you can see this stake, how much ice has gone away. And this is now the current status of the stake in 2025. About 2 to 3 meters of the glacier ice has already gone. You can easily work out from here. And same, for both the glaciers, you can see it. We have installed in 2023. And what is the scenario of this glacier in 2025? And in the background, you can see this is an automatic weather station located about 67 meter, 56 meter above sea level. One of the highest automatic weather stations in the Ladakh region, which we are maintaining in this area. And now if you look here, this is our NIH base camp in the Ladakh Himalaya near Khardungla top. Many people might be knowing about the Khardungla top. So here we have this automatic weather station installed there. And this is again this 56 meter elevation automatic weather station on the Fuche Glacier. And these are some automatic weather stations we are maintaining on the surface of the glacier there. And this is at the Khardung Glacier. And these are some stakes also there. And one hydrological station is also there on the Ganglas catchment, which we are monitoring in the Ladakh region. And this data we are collecting right from 2010 onwards. And about 15 years have been that we have been monitoring these glaciers in the field. Now looking at the overall study from one of our colleagues, one of our friends. So you can see Himalayan glaciers may vanish in the long run. You see, these are the data from different studies, like we have this Azam et al., we have Inset, we have Pratap. Everybody studying these glaciers throughout the Himalaya. We are seeing that glaciers are losing the mass. About 94% glaciers are retreating, means losing mass and retreating backwards. And no glacier is, some glaciers have been reported advancing, but in the Karakoram Himalaya. But in general, we have been seeing that glaciers are losing mass and they are retreating backwards. As a result, the glacier lakes are forming that are posing direct hazards to the community, to the people downstreams. And another disaster which is there, which may be a long-term disaster, that is the water crisis may be there. So these are the consequences of this glacier loss. So here it becomes very essential that we should conduct the frequently glacier mapping, develop the glacier inventories, and monitor the glaciers using geospatial technology as well as the glaciers in the field, so that a holistic and well-managed strategy for water resource management, disaster management can be developed well in time. So these are the concluding remarks. We know that remote sensing has been a game changer in studying the glaciers, studying the cryosphere, because we have the panoramic view, regional scale glacier monitoring can be done, large scale glacier monitoring can be done, and those studies should be but supplemented with the field studies as well. And we can monitor the glacier dynamics also over different time periods using different techniques, different satellite data. And this data has the ability to access everywhere in the Himalaya, provided the satellite data is cloud free and snow cover free available, then this becomes really very good data set to monitor the glaciers. And this data has made it possible to monitor the glaciers and understand the climate change dynamics and climate change responses of the glaciers. So satellite data has, geospatial technology has really played a good role in this direction also. So water and other hazard assessment is also done using the remote sensing satellite data. So all these studies are being done for the better decision making and for developing these strategies for managing trans-boundary water resources, for water resource management, and guiding the policy for disaster management, as well as become climate sensitive and resilient in this climate sensitive region of the Himalaya. So with this, I thank you. Thank you all.
Thank you, sir. Thank you to our speaker, Dr. Riaz Mir, for this outstanding presentation and for sharing your valuable expertise, starting from the basic concepts of the glacier to the basic remote sensing parts to the application part of the remote sensing in this glaciology field. So for the participants, I will request them to fill the feedback form. It is given in the chat box. And if anyone has any question, they can ask it in chat box. Someone named Mrityunjay Kumbhokar asked, is the GSI glacial historical data available for free?
Just a minute, I will. Yes, what is the question?
Yes, sir. The question is the GSI glacial historical data available for free?
Actually, I think GSI is a government organization. So if you require that data, you have to put up the application through proper channel and they will provide you the data. And there is also GSI portal, but I don't think the glacier, some glacier related information is available freely in the glacier GSI portal. But the inventory, which is in the form of a book, I think 2 or 3 inventories they have produced. And that data, that book you can take through proper channel by putting up the application to the concerned authority of the GSI.
Okay, sir. Another question is there any difference how to differentiate between the seasonal, perennial, and glacial ice through the remote sense data?
Seasonal, perennial.
And glacial ice.
That is very simple. You can, if you see, I have shown you some pictures showing you the tonal differences, some brightness differences there. So depending upon the visual interpretation and your experience, you can differentiate between the seasonal snow, because obviously the seasonal snow might be very bright. The tone may be very bright, because in one season the possibility of deposition of the dust and other aerosols is very less. But with time, the same snow becomes granular, so the tonal differences, the behavior and the spectral signature also differentiates. And the ice is really very compact and highly metamorphosed. And now that the tonal difference is again different, that spectral signature we can take up using satellite data, using high resolution satellite data, and we can differentiate. And but for this purpose, generally people are using SAR data. I am not sure which data are using, but I have seen many studies there where they are doing the glacier classification mapping. So they are differentiating like wet snow, dry snow, seasonal snow, perennial snow, glacier ice. So that SAR data is very useful for identification and classification of the different classes of the glacier ice, where you can also differentiate seasonal, perennial, and glacier ice. Because obviously these are different depending upon the spectral and physical characteristics of these ice classes. This can be done using satellite data. Your voice is not coming. Anik,
Thank you.
Viswas, I am not able.
Yes. Thank you, sir. I don't think any of other students have any question. No, one question. Yes. How to delineate snout properly, because sometimes dead ice is look like mud or soil.
Yes, again,
I
please
think
repeat.
that will be snow. How to
Yes.
delineate snow properly, because sometimes dead ice is look like mud or soil.
That is what I have told, that the data, satellite data has a problem. Two problems are there generally. Three problems you can take. For example, if we have low resolution data, where we have resolution of 90 meters, for example, MSS data of Landsat. So if resolution is very coarse, very low, obviously glacier snout mapping will be a bit difficult. Another problem is snow cover. If we have seasonal snout is covered by the seasonal snow or snow cover is there, obviously it will be difficult. For example, if you use the winter image, snow is there. You can't identify the glacier where glacier is there. So another problem is cloud cover. If cloud is there on the satellite covering the snout part of the glacier, it will also become difficult for mapping of the glacier snout or glacier boundary. So it is better always to use high resolution data, snow-free data, and cloud cover-free data. And this data is generally available in the ablation season, for example, in the month of August, because at the time of August, most of the perennial or seasonal snow is melting and has gone away. So this particular time period, ablation period, we can use to monitor the glacier snout, and snow-free, cloud-free, high-resolution data can overcome this challenge, and we can demarcate. For example, if you had look in the Google Earth data, you can easily demarcate the snout of many glaciers, which are clean type of glacier, if it is not debris-covered glacier. So that is there. It is up to you. You have to select the correct data set for monitoring of the snout.
Thank you, sir. Many are saying the webinar is very informative and interesting. So that's really nice.
Thank you very much. Actually, I would like to give one thing. online it is not so glamorous, because I don't know who is listening to me, how people are responding to the lecture. Sometimes it becomes a bit, when there is not a direct communication, eye contact between the audience and the speaker. So managing this gap, this communication interlinking is very really challenging. So, but I believe that the people who are connected there have at least understood, starting from the basics, and I have almost covered every part. So I believe that this lecture will help you understand the glaciology, and you will take up studies, develop interest in this field, and do extensive and beyond this basic type of studies at your end. I believe that all the people who are connected there will take up this, I shall say, this suggestion, and I also wish them all the best in this direction.
Thank you once again, sir.
Thank
I
you.
want to thank also our organizing team and technical support team who had made today's webinar possible. Thanks for everyone's participation. So thank you everyone.
Thank you, Anik, and thank you to the Dr. Biswajit Roy Chaudhary and all other people who are there. Thank you very much.